Hi there, welcome back. This has probably been the most difficult part of the radio. It's the one I've been putting off, as I mentioned in the previous video, and for good reason. If you look at this thing, it is a total mess. There's holes everywhere. Some of them are from where the attachments came off, but most of them are from bookworm or woodworm. And when you pick this thing up, it was literally hollow inside. All sort of grains would fall out as the remains of the worm's work spread out all over the floor. It's not a nice way to become popular with your wife, believe me. But the one good thing about it is that its shape is intact. And there are traces of all the screws, all the gadgets that came off here, the pulleys and so on. You had to be able to discern between those and the woodworm ones, but it wasn't too difficult because what I did was I clamped this to a piece of MDF, 1 centimeter MDF, same width as this, the thickness, and the result of tracing and cutting and checking and adapting was that. It came out beautifully. Now, I had to clamp it and drill the holes through to leave a mark on the MDF to make sure that I had everything in exactly the same position. And then I did the drilling that I needed to do, like that. The pulleys at the top there, if you remember, on the left hand side there, and again on here. There's a bit of staining on that MDF, but the integrity of the MDF is not affected. The speaker hole as well. So that now is ready to receive the grill cloth, which I'll show you in a second. The back side of this even makes the damage more apparent. As you can see, it's all eaten away, falling apart literally, but good enough as a tracing mold. And the other one, just put a bit of spray on there just to make it less obtrusive when it's in the cabinet. The screws that hold the speaker have to be pushed in and actually glued from the other side, and everything else is ready to receive all the hardware. Not bad, I'm happy. The grill cloth is not exact, but it's damn close. This was actually some cloth I had which was a lot lighter. It might look very bright on here, but it's actually sort of yellowy. It was tinted or tainted using tea, believe it or not. And the result actually came out very well. So the next step will be to glue that on the front, trim it, and start putting on the hardware, which still needs some cleaning. But on we go. Okay, after more hours than I care to recall or record, the result is here. And it came out very well. The grill cloth was glued on with, actually with wood glue, stretched out carefully and then clipped with pegs to stretch it. After that it was trimmed. And then I started making the necessary holes with a X-Acto knife, and I started fitting the different hardware. Now, I had to be careful with the glue. I didn't want it to fill the holes that I'd actually drilled using the old one as a mold. So I left those open, and then when I had the grill cloth on, I used a needle to actually find the holes before I screwed on the hardware. And using that method, I think I've got everything exactly where it should be. And then, of course, the cleaning was done of every piece of hardware that went on here. And the result is pretty amazing. This is as good as new. Actually, it's better because the wood I've got here is not going to be eaten by woodworm. Those gold elements you see here, it's a bit difficult to see, but these were resprayed with gold paint because they were tarnished. The pulleys were oiled, and the result is ready to go on the radio. Just for completeness, here's the back. We've got the dial lamp screwed in there. And by the way, all the screws, I need to tighten that one. All the screws were derusted, so they actually take on this dark grey hue. I use anti-rust and then I put it in WD-40 and they are back to life. These yellow felt pads are at the back to prevent that the various dials on the front of the radio from scratching against it. The speaker's been cleaned, solder tags cleaned out, and ready to receive the final wires on there. So this is as ready as it's going to be. You would have noticed that there was no dial cord on the front there. So before I put that front on, I've actually got to get the dial cord started on here. And I'll have to look very carefully at the diagram to see how that works, because it starts here with that pulley and then it goes on to the front, and there's actually a drawing which tells me how to do that. But I have to get it started in there before I put that front panel on, which screws on here. And here's the drawing. It's a bit, well, it's not easy. I just have to figure it out. I really am not good at these dial cord restringing, but I've done quite a few. They always tend to work out, and they always tend to take a hell of a lot longer than you believe they will. But nothing's impossible. I better get started. Here's the reason to be cheerful. The front is complete. The dial cords were put on, and as expected, they did pose quite a challenge, but it's now in place. And what we have is they come through those pulleys. One goes across to the left to the bottom and one goes up. And then you've got these dials on 3 sections. They're pretty dim on there, but you can see it move. And at the top here that's the other one. And as you can see, there's a spring on here. Now this takes quite a bit of effort, and the only way to learn to do this is to try it out. It's quite a challenge, but when you get it done, it's actually quite a relief. Then you've got to make sure that the actual indicator is in a position where when you get to the end, as I'm doing now, turning it, there's the max. That cannot go into the pulley, otherwise they'll get stuck. So you've got to position these, and you can actually shift them slightly, which we'll need to do when we do an RF alignment. So this is now in place, and it's been screwed in with those screws on there to the chassis, as you can see, and the front has been put on. So now it's time to do some of the alignments that I said I was going to do. Now I'll show you the back because that's also been completed. And here we have it. We've got the dial lamps in place. One of them was actually burnt out and I had to replace that, but I had some spares. I've tested it, it works. The 2 bottom yellow wires, they are the heater voltage. They're connected to the dial lamps. That's been soldered in place. The magic eye tube has been fitted in the back there. I'll still have to do a bit of correction there. I believe it's too dim. This is an EM34. It's extremely rare, very expensive to replace, and I think I may have a way of getting it to light up a bit more. Speaker's been soldered in, and that's about it. So this thing is ready to do the final alignments and then the final fitting into the cabinet. Right, now it's time to do the IF alignment, and fortunately this particular radio has all the instructions here. And I'm going to do this fairly quickly because I've done quite a few IF alignments in the past, so I don't want to bore you with this. But basically what I've got here is I have signal generator producing the IF frequency of 452 kilohertz. I've put that to the minimum, which in this particular signal generator is 1.4 volts RMS. That's still too high, so it comes through an attenuator here, where I can attenuate by 6, 12, or 18, or any combination of those. At the moment I've got 12 and 6 activated, so I've got 18 dB of attenuation. This thing then goes to the grid of B2, which is that tube at the back, and it's connected underneath. This connection is AC coupled, so it goes through a capacitor. You don't want DC on your signal generator to get back to signal generator, or you're going to have sparks. So the IF frequency, what we've got now is a carrier that's going into the first real receiver tube, the first one that's going to get IF. And what it's going to do is the carrier is modulated with a 600 Hertz audio tone, and I need to tune these two transformers till I get the highest output on the speakers. Now, instead of using the speaker, I've actually desoldered the speaker there, and I've connected the external speaker. This thing's got an external speaker socket. I've connected that to my goodie over there, and I can then choose to use a dummy load or speaker, and that's connected to the scope, so we can see it on the scope. And what do we see on the scope at the moment? That's the 600 Hertz tone, and I'll show you what adjustments you can make to get that tuned. Just to complete the instructions here, they tell you to set it to medium wave, turn the variable condenser to minimum, and there it is at the minimum, totally open. Set the volume control to max, set the pickup and radio switch to radio, obviously. Unscrew the iron cores of the IF coils. I'm not going to do that because I think it's pretty close. Connect a voltmeter via a trimming transformer to the extension loudspeaker socket. Well, basically we've got the oscilloscope connected on there. You could also use an AC voltmeter. Then you apply to G1, grid 1 of B2 a modulated signal of 452 kilocycles per second via a capacitor of 33,000 picofarads, so 33 nanofarads. Well, we've got that with our AC coupled cable there, and then you trim these transformers. So basically you trim the first two and the ones closest to the output, then the other two, then you go back to the first one, make sure it's all peaked, and you can basically seal the cores afterwards so that you don't have any changes. So I'm going to set this up and we'll do that and see if we can get any improvement. I want to set this up to see if you can see the whole procedure. It's very, very simple. I'm looking at the scope there. I've got a 600 Hertz sine wave, which is coming out of the, this is the audio modulated signal coming from the signal generator being carried on the 452 kilohertz carrier. That's going into the first tube there. It goes through that transformer, then that transformer, and then it gets amplified or detected, amplified, comes out of the speaker. And that's actually what's across the dummy load at the moment. And if it could be across the speaker, you could hear it. It's underneath my desk, but it's still annoying. So we'll do it on the dummy load. And now I'm going to start aligning this and see if we can get an improvement. We should get a bit, because in all likelihood, there it's going down. Take my word for it, it's actually going down. Whoa. That's peaked. There it's hit a peak. I'm just looking at the amplitude of that wave. By the way, you've got to keep this as low as possible so that you don't activate the AGC circuit, the automatic gain control, because then it messes up your tuning. Actually, I can put it a bit higher. I'm sure I can put it a bit higher. Let me increase or decrease the attenuation by 6 dB. It's steadier. So I've got half a volt RMS across the speaker. I think that's probably good enough to not mess up the the actual AGC. So we go back on here, and I use a stick, sharpened stick, form a screwdriver so it doesn't mess up my cores. That's what kebab sticks are for. And I'm checking the voltage there, 0.6. Yep, it's peaked. That one's peaked over there. Try the bottom one. It's going down slightly. Oh, there's a peak, 624 millivolts. Right, that peaked slightly. Let's see if this one's been messed with as well. No, it's going down. No, it's almost there. That's the peak. And the last one. Ooh. Okay, that improved a little bit. There's the peak. I'm going to go back there, see if I can squeeze a little bit more out of it. I'm going to decrease the amplitude of the signal just by 6 dB again. Change that. Try and get less AGC effect. There we go. Peaked. That means that our carrier signal at the IF frequency is getting through the system at its optimum amplitude. So we've peaked that, and we improved a little bit. I'm not sure by how much, but I think we've actually improved a little bit. So that's the IF alignment done. And the next thing is the RF alignment. Now, to start the RF alignment, they first tell you where to connect, where to place the, make sure the dials are pointing to for the various ranges. And although it's hard to see here, there's actually a little mark over there, and that's where that one's supposed to be. That's with the capacitor at minimum. There's another mark over here where that one's supposed to be, and there's one over there where that one's supposed to be, and there's another one for the bottom one which is haven't connected yet. There's a reason for me not connecting the a bottom indicator, and the fact is this indicator is missing. So I am not going to be able to, I could make one, but it will be visible and probably make it look like it's been repaired. If it's absolutely necessary, I can do that later on. But the fact is that this is band 2, and band 2 is that band of frequencies, just the first shortwave band of frequencies above medium wave, where we receive absolutely nothing at all. Whereas the other bands all receive very well. Now, the fact that it's receiving nothing is not that it's not working, it is. It's just that in terms of transmissions, there's practically nothing on those bands. So I've set that all to the right positions, and now we see what they want. They then tell you to set the volume control to maximum, turn the tone control to the quality position, in other words, give it as much treble as possible, and connect the voltmeter via trimming transformer to the extension loudspeaker. So the same thing, we've got the speaker socket connected to the scope, so we're meeting those requirements. And then we start the trimming. Now, this part is a little bit time consuming, but what it says is you put for the first one waveband switch in position medium wave, apply modulated signal of 547 kilocycles per second. So what they're telling us is to put get the medium wave, tune the medium wave to the other end of the scale, to the one where it was. It's 0.2 is up here. There should be a marker by 550 something. And indeed there is. You can just see it there. There's the marker. So we'll move that up. Put it in that position. So you need to apply a modulated signal to the aerial via a dummy aerial. Now, dummy aerial is just a I think it's 220k resistor with 100 picofarad capacitor or something. I've got one made up, to the actual antenna socket, and then you trim for maximum output voltage. Coil 38, 24 and 16. If we look at that drawing, we've got 38 there, 24 there, and 16 is that one there. So we're going to trim that for the maximum amplitude. I hope you can see that. It's a bit tough with trying to get everything in a shot, but I've got the signal up there and it's basically not tuned exactly. You can see that at 547 it is slightly out, but on the other hand it's actually not very far out. We'll adjust it anyway. Let's peek it on there. So the RF alignment is slightly out. What we can see here is that it's actually not tuning straight on there. It's tuning just slightly before that. So I want to hear it. I've put it on speaker and I'm going to start adjusting these coils and see if we can shift it up slightly. So the first one is 38, which is that guy over here. You sometimes need to remove some of the wax they've got on here. They actually say it's Vaseline, and they've used that to seal the cores. So you remove that. You can then actually use a very thin screwdriver just to get the core started, but then do not put much pressure on because you will break the cores. That's just got a bit better. Now 24. There's that guy there. That's just got a bit better. I need to reduce that. And 16. 16 is that guy over here. Gone past. That's it, we've done it. Next they say put the pointer on the trimming point 1, which is that first one we saw, and apply modulated signal at 1630. So let's do that. Here we are at trimming point 1. Change that to 1.63. Then you're supposed to trim C43, 24 and 13. So there is C43. C24 is that one, it seems. And C13 is that guy. So let's see what happens when we trim those. Okay, what we've got here is I put 1630 and I was getting nothing. And if you recall, 1630 is with the dial at right at the end of the scale. So I figured this thing was off the scale. So I dropped it to 1620 and we can just hear it. And if I drop it to 1610, it gets louder. Now remember, this is at the end of the scale, so that means I've got to shift it down. There's 1610, 1620. I've got to shift it down and get this as loud as possible, and then I'll move to 1630. So let me start changing those. Oh boy, okay. That really makes a hell of a difference. That's for 1620. Now let's try 1630. It's gone. Let me try the others. Let's try the other capacitors. That's going down. That's going up. Whoa. That's really going up. Reduce the amplitude of the signal. I might be able to get 1630 now. Jesus, not yet. Bloody hell. Let's try the last one. Okay, can I get 1630? I can just hear it. Just hear it. Let me give it more amplitude. Can I tune it now? Oh yeah. Okay, reduce the amplitude. There's the peak. There's the peak. There's the peak. Right. Now what we need to do is go back up to the top. Drop the volume on there. Go back up to the top to 500 and what is it, 547, and do it again, and then come down and do it again. But now we've done the RF alignment of the medium wave, and you get an idea of how we align this thing. I'm not going to do this on camera for all the bands. It's just really boring. But basically that's it. We've done the this would have done the RF alignment. There's one thing to point out. They do remind you that for the top 3 bands, or was it top 4 bands? Top 4 bands, you need to make sure that this thing is on 50%, on half. This is the fine tuning. So I'll do that, and then I'll be ready to polish the cabinet and put this thing inside and do a final reception test. And actually, I think that what I will do is I will do one final video, which will be the show off of the final project and the reception test in one, so that my friend, when she wants to see what a radio looks like and sounds like, can look at the one video that doesn't include a lot of boring technicalities, and she may even be able to get through to the end without falling asleep. So I'll see you soon.